Hi everyone, my name is Tucker Hagood, and today I will be walking you through this problem. So the problem states, here a regression table for estimating environment temperature based on three variables of wind speed, sun angle, and elevation are provided. Fill out all the values that are not provided and specified by a question mark. Based on your findings, could you explain the association between f-test value and t-test? And it gives us alpha equals 0.05. So this is a two-part problem. First, we're going to have to go through these tables and fill out all these question marks using a formula. And then second part, we're going to have to explain the association between f-test value and t-test. So starting off on the table, our mean sum of squares, the formula for that is our sum of squares divided by degrees of freedom. So what that means is our mean sum of squares for regression is our sum of squares regression divided by degrees of freedom. So 1446 divided by 3. And this gives us 482. Our mean sum of squares error, which is 16856 divided by 24, gives us 702.3 repeating. And our f for this, the formula for that, is our mean sum of squares regression divided by our mean sum of squares error. So 482 divided by 702.3 repeating is going to give us 0.686. So now all we have to do is find our t ratios for all of these variables. And the formula for that is the coefficient that we're given divided by our standard error coefficient, which is also given. So our t ratio for our intercept is 30 divided by 64.5, and this gives us 0.465. For wind speed, 5 divided by 8.33 gives us 0.6, and sun angle, 0.5 divided by 0.42 gives us 1.19. And finally, elevation, 0.05 divided by 0.09 gives us 0.5 repeating. Let me get this off the screen. So that's the first part of this problem. Now all we have to do is explain the association between f-test value and t-test. So the definition of an f-test is that an f-test suggests that at least one variable is a useful predictor, and that's any of these variables right here. So in order to look at this to determine if it's a useful predictor, you have to look at the t ratios of these variables, which we just found. A low t ratio is going to yield a low f ratio. Now, if one of our t ratios is significant, meaning any of our t ratios is less than 0.05, then our f-test is also going to be significant. Here, as you can see, none of our t ratios are less than 0.05, so our t ratios are not significant, meaning our f-test is not significant also. And here is the explanation for that. Thank you guys for watching, and I hope you found this video very helpful.